Okay, so today we're going to be problem solving with basic equations in one variable. And we're going to make sure we're writing our let statements. We're going to be making sure we understand what type of question it is. So I think the first thing we need to review is you always want to ask yourself, and I'm here so you can see me writing up here. You always want to ask yourself, is it a total question? Is it a balanced question? Or is it a special case with a fixed value and a changing value? Because those will help us determine what type of equation we're writing. The first thing we want to do is organize our facts to help us write the problem, okay? All right, so first, the example is a pear contains 30 calories more than an apple, okay? 10 apples have as many calories as 7 pears. So we know that our unknowns relate to the calories that are in an apple and the calories that are in a pear. So I've said one of the suggestions is always to write your variable in terms of the item that has the least value. So in this case, it's the apple. So I'm going to let A equal the calories in apple. Okay? And then the calories that are in a pear is 30 more. So A plus 30 equals the calories in a pear. Okay, now 10 apples have as many calories as 7 pears. That's already telling me it's a balance equation because I wasn't given a total value for the calories, okay? So now we need to make sure that we understand that A is the calories in one apple. But now we have to deal with the fact that there's 10 apples. So this would say 10 times the number of calories in one apple. Have as many calories as is implying equals, so equals 7A, or 7 times A plus 30. Now, we need to make sure, because A plus 30 is an expression, that it gets put in parentheses, okay? So I'm going to scroll up a little bit here. All right, so now we solve. So 10A equals 7A plus 210. And then we solve for A. So we isolate the variable. We bring the smaller to the larger. So I'm going to subtract 7A to both sides. And we're going to get 3A equals 210. We divide by 3, so A equals 70. All right, so I'm going to switch colors. So that means that there's 70 calories in an apple, and there's 100 calories in a pear. Okay, so the difference here between what we were doing previously and what we're doing now is that notice that we had to add this multiplier based on the number of apples and pears we had. All right, let's look at our next example. All right. Oh, I'm missing some information here. Okay, so we're trying to find the number here. That should kind of really be up here. Find the number of full 8-hour shifts that Maria worked last month. Okay. So she worked twice as many 6-hour shifts as 8-hour shifts, and she worked a total of 280 hours. So already in my mind, I'm thinking it's a total equation. All right, so I'm going to set my variables, and it looks like she worked 8-hour shifts, and that's actually what they're asking me directly, and that happens to be the least in this case. So I'm going to let X equal the number of 8-hour shifts she worked. Okay? All right, and then I'm going to let 2x equal the number of 6-hour shifts. Now, we know that she worked a total of 280 hours, but remember, these let statements are not in hours, okay? They are the number of shifts. So this is where we have to get that multiplier. All right, so the 8-hour shifts, she worked X of them, so it would be 8 times the number she worked, plus 6 times the number of 2-hour shifts, which was 2x, and that's going to give me my total hours of 280. Okay, all right, so we do 8x plus 12x equals 280. So 20x, I'm going to go over here, 20x equals 280. So x equals, let's see, it goes into 28 one time with 8. So 14. So she worked 14 8-hour shifts, okay? All right, so I want to notice in the above examples that for one of the scenarios, you set things equal to each other. That's what I call the balance equation. And in the second, you added the scenarios to equal a total, okay? All right, so the word total definitely helped us a lot, okay? And in the first equation, I'm thinking that 10 apples have as many calories as also kind of helped us know that it was a balance equation. All right, let's move on to some harder word problems. All right, so sometimes now we're not going to be just writing two let statements. Sometimes we have to consider the third piece of the puzzle or someone that relates to something else. All right, so we want to always read them literally as well. Brian earns twice as much each week as a tutor than he does pumping gas. His total weekly wages are 150 more than that of his younger sister. She earns 1/4 as much as Brian does as a tutor. All right, so sometimes that thought that we use the smaller value, we have to be really careful, okay? Because in this case, we're really looking at Brian, okay? We're looking at Brian. So we want to pick Brian's lowest value, okay? All right, now the question asks me about his tutoring, but I realized that he makes more tutoring than he does pumping gas, so I decided to go with Brian on his smallest value. So I let X equal the amount he makes pumping gas. I'm going to put PG, okay? Amount he makes pumping gas. So then 2X would be the amount he makes tutoring. Okay? If I didn't do it like this, then what would happen is if I let X equal the amount he makes tutoring, then the amount he makes pumping gas would have to be 1/2 of it. So we'd be adding fractions to the equation that I don't really want to add if I don't have to. All right, but now we've got to deal with this younger sister thing, okay? So it says his total weekly wages are 150 more than that of his younger sister. Okay, so his total weekly wages are X and 2X, which is 3X. And he makes 150 more than his younger sister. So I put minus 150 as that gives me the amount younger sister makes. Now, why do I need that? Well, because it says in the next part, and let me the blue part here, she earns 1/4 as much as he does as a tutor. So I need to have a variable that relates to the sister in terms of Brian, because the variable is based on Brian. All right, so now we're going to read everything literally. She earns. Well, she earns 3X minus 150. Okay? She earns 1/4 or 1/4 as much. So 1/4 as much as Brian does as a tutor. So I only have to worry about him as a tutor, which is 2X. Okay? All right, so now we're going to simplify. And we get 3X minus 150 equals 1/2 X. All right, so it's Coach Fred. She's going to clear fractions because she sees fractions. So she's going to multiply everything by the LCD, which is 2. All right, so that's going to give me 6X minus 300 equals X. All right, let me move up a little bit. Ooh, I can't. Okay, so actually, let me see if I can add a page here. Oh, you know what? I'll come up here. All right. So I'm going to subtract X from both sides, and I'll get 5X minus 300 equals 0. I'm going to add 300, and I get 5X equals 300. So then X equals 60. All right, so 60 is how much he earns pumping gas. The question says how much does he earn as a tutor, which is 2 times X. So $120 is my answer. Now that one was a little bit harder. You had to write 3 variables. You had to go back to the question and see why you needed the 3 variables. So that can get confusing. All right, let's move on. Sometimes it's you're going to be given problems that involve drawing a picture. And those are usually the geometry relating problems, okay? So it says a roll of carpet 9 foot wide is 30 feet longer than a roll of carpet 15 feet wide. Both rolls have the same areas find the dimensions of each. And you know what? As I'm reading this, I really think that they should have told us that the roll of carpet was rectangular. So I'm going to let you assume it's rectangular. So I actually have two different carpets. So I draw my two carpets. All right, a roll of carpet that's 9 feet wide is 30 feet longer than a roll of carpet that's 15 feet wide. So I've got one that's 9 and one that's 15. All right, so it's longer than, so I'm going to let L equal this one, the 15, and the 9-foot one, its length is 30 feet longer than that, so I'm going to make it L plus 30. It says both rolls have the same area, so I need to calculate the area of each. So we'll call this carpet 1 and this carpet 2. So the area of carpet 1 is 9 times L plus 30, making sure to put L plus 30 in parentheses, remembering that the area of a rectangle is length times width. All right, and then the other one would be 15L. Now that's a basic equation that you know how to solve. So I'm going to distribute the 9. I'm going to get 9L plus 270 equals 15L. I'm going to subtract the 9 from both sides, and I'll get 270 equals 6L. Okay. I'm going to divide by 6, and I'm going to get L to be 45. All right, so now going back, the question asked me find the dimensions of each. All right, so the first one is going to be 45 by 15. And then the other one is going to be 75 by 9. And those are my two answers. Okay, so that one, not too bad, but remembering those formulas can sometimes be tough. All right, going on to our last example. Sometimes we have to write variables and then change them because we're given information and then we're given more information that helps us write a problem. So let's read this question. In March, Rodney sold twice as many cars as Greg. In April, Rodney sold 5 fewer cars than he did in March, while Greg sold 3 more cars than he did in March. If they sold the same amount of cars in April, how many did each sell in March? So I know that the question's asking me how many they sold in March, but I see that they are giving me information about my equation based in April. So I got to do some work here. All right, so I'm going to start by going to how many did each sell in March, because that's the question being asked, and I'm going to pick the one that sold least. So in March, Rodney sold twice as many as Greg, so I'm going to let G equal cars sold by Greg in March. Okay, so actually what I'm going to do is I'm going to put the word March up here. All right? All right, so then Rodney sold twice as many, so 2G. Cars sold by. Sorry about my handwriting. I ordered a new stylus. It's not here yet. Okay. Cars sold by Rodney. Okay, but I think you get the idea. All right, so that's March. Now we're going to bring in the April piece. Okay, I'm going to actually switch to black here. So we're going to bring in April. So in April, Rodney sold 5 fewer cars than he did in March. So that would be, I'm going to put April up here. All right, he sold 5 fewer, which would be 2G minus 5. All right. Well, Greg sold 3 more cars, so that would give me Greg as G plus 3. So we wrote our equations, we changed them because April is what we need to write our equation. They sold the same amount in April, really is telling me that they were equal in April. So G plus 3 equals 2G minus 5. Okay, so go ahead and solve that for G. Let's see what you do. I'm giving you a second. You can pause if you need to, but I'm counting. And I believe that if you subtracted G to both sides and added 5 to both sides, you would get G equals 8. So that means that in March, Greg sold 8 cars, whereas Rodney sold 16 cars. Okay? All right, so now the problems that we're going to be doing in class are going to be based on all of these different types, and we're going to put it together and make sure that we remember everything that we can, okay? And then we'll take that piece a little bit farther in a few days. All right, hope you have a great night.